Let's take a look at the operations within the complex number system. Remember the operations that we have in mathematics, the four basics: addition, subtraction, multiplication, and division. We're going to look at the first three: addition, subtraction, and multiplication. Let's begin with addition. To add two numbers within the complex number system, remember a complex number is the real number plus an imaginary number. And we're going to add on another real number, and this time minus a complex number. So if I take 2 plus 3i plus 7 minus 3i, to add these, I can simply get rid of the parentheses, 2 plus 3i plus 7 minus 3i, and then combine like terms, just like we would in the real number system, treating I as a variable. So here we have 2 plus 7 as our real number, 9, and 3i minus 3i gives us 0 i's, so we leave it as 9. So within our complex numbers, we added two of them, and we ended up with simply a real number. Another example of addition, to where the i's don't cancel. Let's say we have 3 plus 9i, and let's add to it a negative 4 plus 2i. Again, nothing is happening to either one of these quantities or numbers, so we're going to bring them out of the parentheses and then combine like terms. Remembering this is a negative 4. So we have 3 plus the negative 4 gives us negative 1, and 9i plus 2i gives us 11i. And there's our final answer. Subtraction is going to be very similar to addition. Remember, addition and subtraction are inverses of each other to start with. So if I take a complex number, 2 plus 2i, and subtract from it, say 3 minus 4i. Here, we have to take this negative and distribute it into this complex number. So our first number, 2 plus 2i, stays the way it is, minus 3 plus 4i, as we distribute this negative to each of our numbers. Now it becomes just like addition. We're going to combine like terms. So we have 2 minus 3 gives us negative 1, and 2i plus 4i gives us 6i. And there's our final answer. We can also place a scalar in front of our quantity. Remember, a scalar is simply a number. So this will be example 4. Let's say I give you 2 times the quantity, 3 plus 2i, minus 4 times the quantity, 1 minus 5i. Here we're going to multiply the 2 through. So we have 6 plus 4i. Multiplying the negative 4 through, we get negative 4 plus 20i. Combine like terms, 6 minus 4 gives us 2. 4i plus 20i gives us 24i. And there's our final answer. Multiplication is going to bring a couple of new things for us. So let's go ahead and look at multiplying two complex numbers. Let's take 2 plus 3i and multiply it by 4 minus I. Now this is going to look like a multiplication problem of binomials, and we're going to treat it just the same to begin with. We're going to distribute the 2 to each of our terms in the second quantity. So 2 times 4 gives us 8. 2 times negative 1 is negative 2i. We're going to multiply the 3i to each of our terms in a second as well. 3i times 4 gives us 12i, and 3i times negative 1i gives us negative 3i squared. We can combine like terms just as before. So we have 8 plus 10i, negative 2 plus 12, minus 3i squared. And most of us would say, hey, this is done. However, let's examine a little more this I squared here. So this I squared, remember I equals the square root of negative 1. Well then I squared would equal the square root of negative 1 times the square root of negative 1, or I times I. If we take the square root of a number times the square root of itself, we'll actually end up with the radicand, or the number under the radical. So I squared actually equals negative 1. With that information, we can come in here and simplify then I squared. So we have 8 plus 10i minus 3 times negative 1. Negative 3 times negative 1 can be simplified. So we have 8 plus 10i plus 3. And 8 plus 3 gives us 11. So we have 11 plus 10i. So notice we don't end up with the trinomial that we normally would when we distribute two binomials. We end up actually with another binomial. And this is our final answer. Let's take another example of multiplication just to reiterate what happens. So this ends up being example 6. Let's take 2 plus 9i and multiply it to negative 1 minus 2i. Here we end up with 2 times negative 1, negative 2, distributing, minus 4i. Multiply the 9i through, we get negative 9i. And then 9i times negative 2i is negative 18i squared. I'm going to combine my two middle terms. So negative 4i and negative 9i is negative 13i. And negative 18i squared, remember I squared is negative 1. So negative 18 times a negative 1 gives us a positive 18. So negative 2 and 18 gives us 16 minus 13i as our final answer. We can get a little more complicated on the multiplication side. We can actually multiply 3 terms together, or we can throw a scalar in there as well. So let's look at just 3 monomial imaginary numbers. So let's look at 3i times 2i times 4i. Well, 3i times 2i is 6i squared. 6i squared, remember I squared is negative 1, so we get negative 6 times 4i, which ends up being 24, or negative 24i. Now the question becomes, do I really have to simplify that at that point? And the answer is no. We can actually multiply 6i squared to 4i, and you end up with 24i to the third. Remembering I to the third, we can break up into I squared times I squared being negative 1. So we end up with 24 times negative 1 times I, which is equal to negative 24i. Notice we get the same answer either way we choose to do it. So to recap what we've done today in our operations in the complex number system, we added by simply adding like terms. We subtracted, remembering we're going to multiply the negative through before we go ahead and combine like terms. And we also looked at multiplication, where we're going to distribute the first quantity into the second quantity. We also saw that I squared was equal to negative 1. And that will conclude our operations in the complex number system.